So welcome to Jumbo IS and welcome to lecture number 1 of Geography Environment of this lecture series called Prelims Powerplay 2026. Through this lecture series, we will revise your entire syllabus of UPSC Prelims examination. That includes static portion as well as current affairs. Everything would be covered. And you just have to spend 1 hour every day from today till your prelims examination. That's it, 1 hour. And everything would be revised. Now, along with these lectures, you shall get notes. You shall get access to our WhatsApp groups where you can ask your doubts, and you will be getting a test series to practice whatever we are studying. Now, lectures would be there on YouTube, but for notes, for WhatsApp groups, and for test series, you would have to register on our app or on our website. The registration details are given in the comment section below. Okay. Plus, a number is also given in the comment section. If you are finding any difficulty for registration, well, you can WhatsApp us on that number. Okay, so do start. You will be just spending 1 hour every day, but everything would get revised. You don't have to refer to any other source. This would be enough. All right. Today we are starting with geography and environment. As you all know, we have covered polity portion. We have covered economics portion. Now today we are starting with geography environment. And our today's topic of discussion would be El Nino Southern Oscillation, ENSO. Now you must have heard about El Nino, La Nina. They're collectively known as El Nino Southern Oscillation, and it has a huge impact on Indian climate, but not just Indian climate. It has a huge impact on the global climate. Now, what is this El Nino Southern Oscillation? It is very important for you to understand because it is always in the news, and current affairs related questions or static geography related questions can be asked in your prelims examination. So we will understand El Nino Southern Oscillation in its totality. So pay close attention. All right, so let's begin. So geography environment, lecture number 1, El Nino Southern Oscillation. Okay, El Nino Southern Oscillation impacts global as well as the climate of Indian subcontinent. Okay, now to understand El Nino Southern Oscillation, you have to understand a certain background with respect to Pacific Ocean. Okay, we are going to focus on equatorial Pacific Ocean in the equatorial region. You need to understand certain things about it, and then we'll get to El Nino Southern Oscillation because only then you'll understand. Okay, so under normal conditions, when there is no El Nino or La Nina, under normal conditions, this is the situation. Okay, as you can see, this is Australia, this is South America, and this is the equatorial Pacific Ocean. Okay, now pay close attention. Generally, what happens is that, well, the ocean waters, the sea surface temperature in this region is a little bit cooler. And near Australia and Indonesia, it is a little bit warmer. So sea surface is warm over here normally and cool over here. Because sea surface is cool over here, the temperatures are low. Because the environment, the weather is cool over here, because colder temperatures are there as compared to this portion, well, the air tends to descend. Okay, and because warmer temperatures are here in near Indonesia and Australia, air tends to rise. You all know warmer temperatures allow air to rise upwards. So air rises upwards over here, air descends over here. Because of this, close to sea surface, there is high pressure near South America, and there is low pressure near Australia. Clear? This you need to understand. High pressure conditions, low pressure conditions. And you all have studied that, well, wind blows from high pressure to low pressure. So because high pressure conditions exist over here, well, wind tends to blow from South America towards Australia in the equatorial Pacific region. Okay, this wind carries moisture from the Pacific Ocean and brings rainfall to Indonesia, Australia, and even strengthens monsoon in India. Okay, but wind tends to blow from east to west in this direction. Okay, now these winds are called trade winds. Simple. This is the, let me write over here, this is the default condition. Okay, or normal condition. So wind descends over here, okay, rises over here, it blows from here to here, then it rises, then it comes back, descends. This circulation, this movement, circulation is known as Walker cell or Walker circulation. Just remember the name for now. Okay, simple, yes. We'll talk about Walker circulation in the end, but just understand this is the normal position. But, well, sometimes, not always, sometimes, well, this cool water over here near the Pacific Ocean, this cool water over here, it becomes warm. And sometimes even warmer than Australian Pacific Ocean or Indonesian Pacific Ocean. And when it becomes warm, it disrupts the entire Walker circulation or this entire trade wind circulation. This condition is known as El Nino. Then sometimes this cool water over here becomes even colder. It is not warm, it is colder, very cold. This is known as La Nina. You understand now, okay? The water over here, when it becomes warm, hot, El Nino. When it becomes cold, La Nina. And when it is normal, well, we say neutral conditions exist. Normal is generally cool, La Nina is cold, and El Nino is warm. Now, these things happen periodically. El Nino, then neutral, then La Nina, then El Nino again. This happens periodically, and that is why it is known as a cycle. It oscillates between El Nino to La Nina, and that is why it is known as El Nino Southern Oscillation. It oscillates between El Nino to La Nina. Simple, okay? Now, first let's talk about El Nino. What happens in El Nino, okay? So, first let's talk about El Nino Southern Oscillation, okay? You understood the default position? Now, El Nino Southern Oscillation is a naturally occurring large-scale climate phenomena that involves periodic fluctuations in sea surface temperatures, okay, and atmospheric pressure across tropical Pacific Ocean. When it's warm, El Nino. When it's cold, La Nina. Now, El Nino Southern Oscillation has 3 stages. El Nino, the warm phase, La Nina, the cool phase, and then there is neutral phase, which is this default position. Simple, and they keep on repeating themselves. Hence, it is known as El Nino Southern Oscillation. Now, this cycle typically reoccurs every 2 to 7 years. Every 2 to 7 years, it repeats entirely. Remember this fact? And each phase lasts for 9 to 18 months. So, El Nino will last from 9 to 18 months, La Nina also, neutral also. Clear? Simple? So, this keeps on going. Now, let's talk about each and every phase one by one. First, let's talk about El Nino phase. Now, remember, during El Nino phase, this water becomes warm. Okay? And this water is relatively less warm. Now, remember, there was low pressure over here and there was high pressure over here. Clear? Yes? Sorry. It was the opposite. There was, in normal conditions, high pressure over here and low pressure over here, because of which trade winds used to blow from here to here. Simple? Yes? Now, what happened was that when El Nino occurs, this becomes warm. It warms up the entire air around it. So, air starts to rise over here. This area from high pressure transitions into low pressure. And earlier, when trade winds were blowing in this direction, it weakens them or sometimes even reverses them. Yes, this is known as El Nino phenomena. So, when warm water appears in this region, it is known as El Nino phenomena. Abnormally warm sea surface temperature in central and eastern tropical Pacific Ocean. Central and eastern tropical Pacific Ocean. Now, trade winds blow from in this direction, from Atlantic Ocean to South America, from South America to Pacific Ocean, then to Australia, Southeast Asia. Trade winds blow in this direction. Generally, what happened was, when trade winds are strong and they're blowing very fast, the sea water over here is transferred in this direction. And the colder water from down below. So in this area, the water over here is pushed away by the wind and the colder water from down below replaces it. This is known as upwelling. Because trade winds are blowing so fast, normally, it pushes away the warm surface water and downwards water comes up, which is cold. Okay, this happens. But during El Nino, because trade winds are weak, this upwelling is not happening. And this water keeps on becoming warm and warm and warm. This happens. Okay. So, weakened easterly trade winds and reduced upwelling of cold nutrient-rich water along the South American coast. This is what happens. This is the thing. This is El Nino. Clear? Now, remember, when El Nino occurs, well, it impacts the entire climate or weather of the planet. Okay. It's just a small thing. Warm water appears instead of cold water, but it impacts everything. Okay. What are the impacts? First of all, whenever there is El Nino, well, there is very little rainfall in India, Australia, and Southeast Asia, Thailand, Indonesia. Creates drought-like conditions. Monsoons are very weak during El Nino. Okay? Then all over the world, including India, temperatures are more above normal global temperatures, plus heat wave-like conditions occur everywhere. Then there is drought-like condition in India, Australia. There is heavy rainfall and flooding in South America, East Africa, and Southern United States. So over here, there is drought-like conditions in this area, drought-like conditions, flood-like conditions in this area. This is what happens during El Nino. Plus, the thing is that because trade winds were blowing very strong during normal phase, the downward cold water used to come upwards. And it also used to bring a lot of nutrients along with it from seabed. These nutrients allow fishes to flourish. Okay, this nutrient-rich water allows growth of plankton and fishes multiply. So fishery growth happens over here. So during normal times, well, the fishermen catch a lot of fish. Marine biodiversity is high. But during El Nino, there is no upwelling, there is no nutrient-rich water, and fisheries resources also decline, which is bad for marine biodiversity in the South American coast. Make sense? Simple? Okay. Now this is El Nino. This is the impact of El Nino. More examples are given in your notes. These are just 4 examples what happens during El Nino. Okay. But more examples are given in your notes. By the way, remember, whenever there is El Nino, winters in North India are also not that strong. They're very weak. But whenever there is La Nina, winters are strong. So let's talk about La Nina. So during La Nina, water is extremely cold over here. Because of that, extremely high pressure situation is here. Extremely low pressure situation is here. Well, this high pressure, low pressure difference is even stronger than normal circumstances. Trade winds are blowing extremely strongly. They further push water in this area left, and downward colder water comes up, which further strengthens colder temperatures in this region. Okay, this is La Nina, cooler than average sea surface temperature in the same region. Strong easterly winds and increased upwelling. Okay, and what is the impact? The exact opposite. More rain in India, Australia, Southeast Asia, monsoon is strong, cooler temperatures, and winters are extremely cold. Currently, La Nina conditions are going on, and that is why they're predicting that winters in North India are going to be cold this time, because La Nina is there. Drought-like conditions in South America, Central America, Southern USA also. And because there is upwelling, there is enhanced marine life, because upwelling brings nutrient-rich water, which is good for fishes. Fishes multiply, good for fishermen. Simple. And then there is, simply put, ENSO neutral. Okay, so there is El Nino, La Nina, neutral. What is neutral? This default position. This is neutral. Clear? So neutral. Let's talk about neutral. So neutral conditions often act as transitional phase between El Nino and La Nina. So El Nino converts into La Nina after neutral, then La Nina to El Nino, neutral. So neutral is a transition phase. Sea surface temperatures in Central and Eastern Pacific equatorial are close to long-term average. Cooler, not cold like La Nina, cooler. This is considered the default state for climate system and occurs more frequently than El Nino or La Nina. But the problem is, when there is a strong El Nino, weather people, weather scientists, climatologists know what to expect. When there is La Nina, they know what to expect. But neutral conditions, well, it is quite unpredictable. And you don't know how the weather is going to behave in Australia, India. Predictions are very difficult during neutral phase. So weather predictions can be more challenging during neutral periods compared to strong El Nino and La Nina phases. Simple? Make sense? Yes? Okay. So this is El Nino and La Nina and their impacts, and this is ENSO neutral. Now they repeat themselves again and again within 2 to 7 years, and this is El Nino Southern Oscillation. Now, remember I used the word strong El Nino, strong La Nina, weak El Nino, weak La Nina. How do we measure whether El Nino or La Nina are strong or weak? There must be some measurement, right? So how do we measure it? Well, to measure El Nino and La Nina, we have this index called Southern Oscillation Index. Now, what is Southern Oscillation Index? Look at this map. Okay. Look, whenever there is La Nina, There is high pressure over here. There is low pressure over here. Just a second. Low pressure over here. Okay. Now we take the difference between the two pressures. Okay. Pressure in near South America minus pressure near Australia. We take the difference between the two. If the difference is huge, strong La Nina. If the difference is less, weak La Nina. And if the difference is negative, that means pressure over here is low and pressure over here is high. That is El Nino. Because during El Nino, there is warm, during El Nino, there is low pressure over here and high pressure over here. Yes? So pressure is low over here. So this is less, this is more. Okay? So the value of Southern Oscillation Index is low. What is Southern Oscillation Index? Basically, you check the atmospheric pressure near Tahiti. Tahiti is near South America, and Darwin, which is near Australia. Okay? Make sense? So you calculate the pressure over here and here. You subtract the pressure of this place from this place. If the difference is positive, La Nina, negative, El Nino. You understand? So let's read it out. So SOI is calculated based on monthly or seasonal mean level pressure difference between Tahiti, which is near South America, and Darwin, which is near Australia. Clear? Now, typical SOI values range between minus 35 to plus 35. If it is minus 35, then very strong El Nino. If it is plus 35, then very strong La Nina. Okay, what is the history of this index? SOI data has been recorded and analyzed since the late 19th century, offering a long-term perspective on ENSO variability. So just take a look at this. Okay, when El Nino conditions are there, well, negative SOI values, and it is typically more than minus 7, minus 8, minus 9, minus 10. La Nina, plus 7. More than plus 7 is La Nina. And if it is between minus 7 to plus 7, close to 0, then it is neutral conditions. Make sense? So if it is between minus 35 to minus 7, then El Nino. If it is from 7 to 35, plus La Nina. And if it is between minus 7 to 7, neutral, which is close to 0. Yes, this is how you measure it. Make sense? Now you have understood ENSO. It is very simple. Okay, very simple. You understand it now. If there are any doubts, do ask those doubts. But there are a few terms that I want you to understand. Okay, because questions can be asked from these terms. So number one is Jerkness feedback mechanism or Jerkness feedback mechanism. Now what does Jerkness feedback mechanism say? Okay, it is related to ENSO only. A crucial positive feedback loop between ocean and atmosphere that explains the development and intensification of ENSO phenomena. What does this feedback loop say? Pay close attention. Okay, let me explain what does this feedback loop say. This feedback loop says that let's talk about La Nina first. Okay, cold water appears over here, which strengthens trade winds. Because trade winds are strong, they further push away water from South America to Australia. Downward, even colder water comes up, which is even colder, which further strengthens trade winds, which further allows colder water to come up. This goes on and on and on. So cold water strengthens trade winds strengthen even colder waters. Yes, so there is a link between trade winds and upwelling, right? Similarly, during El Nino, warm water appears. Yes, because warm water appears, trade winds are weakened. There are no trade winds. Okay, because there are no trade winds, no water is being pushed in this direction. No upwelling is happening. Water keeps on becoming warm over here. So it is further strengthened. El Nino is further strengthened. This feedback mechanism, that cold water, strong trade winds, again colder water, this feedback loop is known as Jerkness feedback loop. It is called Jerkness feedback loop or Jerkness feedback mechanism. Remember this, okay? It is named after meteorologist Jacob Jerkness, who discovered this in 1969. This shows how sea surface temperature and atmospheric winds mutually reinforce each other. Clear? Simple? Okay? So that is Jerkness feedback mechanism. And now let's talk about the last topic, and that is Walker cell circulation. So what is Walker cell? You remember I explained Walker cell in brief in the beginning of this lecture. So look at this image. This is Walker cell. During ENSO neutral conditions, Okay, water is cold near South America. Okay, let me change the color. Yeah, so water is cold over here, water is warm over here. Okay, so air descends, air rises over here, and the descending air comes down, moves in this direction. These are trade winds. When they move upward, they form clouds and do rainfall, and then they go back to their default position and then descend downwards. This entire movement is a cell-like movement, circulation, and this is known as Walker circulation. Let me change the color again. Walker circulation. Okay. Now, during El Nino, Walker circulation is weak. During normal, it is normal. During La Nina, it strengthens. Okay. So look at this. During El Nino, Walker circulation weakens or sometimes even reverses, leading to drought in the Western Pacific and flooding in the East. Western Pacific is Australia, Indonesia. Okay, this is El Nino, and even India also. La Nina, the Walker circulation intensifies, causing wetter conditions in Western Pacific, heavy rainfall in India, Australia, North Australia, Indonesia, and drought-like conditions in South America. Clear? So this is Walker circulation, and this is all you need to know about El Nino Southern Oscillation. Though some extra things are mentioned in your notes, do check that out. It is very important. All right. So that would be all. With that, we conclude today's session, today's lecture. We covered El Nino Southern Oscillation. I hope you understood everything, and I'm sure it has added value to your preparation. But it will add more value if you revise the lecture, ask your doubts, and be regular with the test. These three things have to be fulfilled. Only then this lecture series will allow you to clear your prelims examination. All right then. That would be all from my side, guys. I'll see you next time with another topic in this lecture series called Prelims Powerplay. Thank you, everyone.